Hey guys, welcome back. It's your Mathman, and I've recorded a lot of videos today, but let's keep going. Why not? Today we're going to head on to episode 1 of Infinity because I think the series is in high demand. I've had a lot of people IRL tell me, "Oh, you should do the series. It would be an excellent thing for your channel. It would tell me a lot about X, 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 and X." And that's true because there are a lot of good programming practices that I can see happening here. So we're just going to dive directly right into the code, because last episode we didn't do any coding at all. We just set up the project, and that was kind of a pain to do. Or really, I had the project already set up. I just didn't want to explain what was going on. So I'm not sure if I did indeed grab the updated version. If not, I might have to re-clean it again, aka re-delete everything, because I did a lot of pre-tests and pre-code before actually writing this series. And I've experimented with different types of data structures that might actually be necessary. Yeah, so you can see all this different stuff. Let's just close, because I really don't need any of this. I actually might have to go through with that because, mind, please. Because I'm going to delete all of this, and I'm just going to restart fresh. Come on. There you go. And the reason why I want to start fresh, just ignore everything that you see here, is that so you can follow along the series word for word. So let's delete this. Let's delete target since we really don't need target. Let's delete the properties file since that really doesn't do us much help anyways. So let's just do command delete files for clean build. Ta-da! And let's go ahead. That's a lot of messages. But that just clean everything up. So let's grab this and let's make a main class, because every application needs a main class, am I right? And the main class is just our entry point. If you're new to coding, I advise you do not watch this, because it is a bit difficult if you don't know how to code Java. I might plan to launch a series on that as well. That goes from absolutely everything. I do not want to hit main because I did not implement the method. Go away. Implement methods, thank you. But come on, there's like crumbs on my desk, so not crumbs, I mean like eraser marks. There we go. So let's go ahead and do something like this. So let's just, I did set up another main class last episode, so but we're just going to continue with our regular daily schedule. So show, and then we're going to do add main, commit, and then it says unversion like 24 files. I'm pretty sure it falls on the target, but whatever. Because there is a bunch of unresolved things. See, a target. Yeah, holy crap, that's a lot of things. Let's just delete that folder because it doesn't seem, it's excluded, so typically things that are excluded you can delete. And you can see that it just says, yeah, there should be nothing in the project, but okay. Fine by me, I'm not going to involve with that. So the next thing we want to do is, well, let's clean this up first. Is that, I'm going to make a bunch of delegates, so let's do, because I accidentally cleaned up main, clean main. And let's go ahead and make a delegate. So in IntelliJ, if that's the ID that you're using, you just do delegate right here, which is under, what's it called? Refactor extract delegate. And I want to make everything into a delegation class instead of the actual main class, because it's just good architecture because it makes things easier to use. So I'm just going to call this namely application infinity, and that's it, run. And so it's just going to make a delegate like this. So you notice now we have start. So what happens is that under application there is a method called stop public void stop, because software parallelism. Infinity.stop. And software parallelism is a tendency or possibly the intentional design of architecture of a software such that it's kind of, parallel. Like two things go well with each other. You have a positive and a negative, or a light and a dark, or whatever. In this case, you have start and stop. So also we have get and set, and add and remove, and just those are just examples of parallelism in software, and that's kind of important to note because it's a common pattern that you'll see. So let's just do extract delegate from main. And that's the first thing that we want to do because it makes things unit testable. Slightly. So the first thing that we have is that we're going to be working with fxml a lot too. So let me pop in a resources thing. I actually do have one already. Whoopsie. Yeah. So let's, come on, thank you. And let's pop in, let's make a new fxml file. I'm just going to call this guy. We need the directory first, so com.meti app. And I'm going to talk about why I put app there for a second. The com.meti part is pretty understandable because meti is the name of the organization that I'm going to make this package under. It's also what the GitHub repo is going to be under, so that's important to note. I'll go ahead and put a link to the GitHub so you can make a fork out of it anytime to any of these episodes and contribute. Because this is an open source project. I might not be able to figure out what code was changed if you do a pull request, but I'll be able to follow along in what forks they have and what episodes are covered. So let's just do display. And just like so, it makes a new display class, and then just do create class empty main. And let's move this out of the resources directory since this should not be here. And let's just move this to a new package. com.meti app. So, and let's just do create display, because that's what we did. We created the display. There's not much to say there. And let's grab these two and let's plop them in here and continue. It's accessible. Yeah, so just changed everything up here. And let me just cut this out. Meti.app, delete. Organize. There's not much to say. Organize. We change the code, we factor it in so it actually becomes usable. And display. So for display, let's go ahead and pop open Scene Builder, which is an application I have here on this computer, so I can go ahead and modify these fxml documents without having to. It's a drag and drop system, so instead of doing that, I can just pop open here and edit the file as we'd like, instead of, having to manually type out everything, which is what you could do, but it's horribly inefficient. And it's not, humans are spatial creatures, so it's always good to have a spatial tool that allows you to work with whatever you're working with on hand. So let me just move this down because of picky. And so that our controller's hooked up. So this is what we have our blank fxml. And the reason why we have a blank fxml is we want to actually, I forgot to hook it up to infinity. Let's do something, let's cut this out. fxml load, get class, get resource, meti.app / display.fxml, because this is just points to resources, and this just says get resource, so it just says resources. Pretty self-explanatory. So applying try catch because I don't want to handle this at the moment. We are going to handle this at a later date. So to do handle exceptions. And let's just do something like this. So attach display.fxml to infinity, like so. Commit. Anyway, so in here what we're going to do is actually no, the first thing we need to do is we need to make an idea of what features we want. And what annoys me that it's not the name of our project, it's just final infinity. Thank you. So it just collapsed it back into the original. We gotta refresh. Okay, fine by me. Fine by me. But let's make a new folder. And we'll call this guy directory and scratch. It's just going to be a scratch work of anything that we want to include. And it's just mark directory as generated sources. No. That qualifies in none of these. So let's do ideas.md, and I have markdown on here, so we can go ahead and edit the markdown. So I typically, it's a formatting thing. So I'm opening it for markdown editor, then that makes everything much easier to see. So ideas this file contains all of the possible ideas / features / potential outcomes of this project. I type really fast, so that really helps with making huge text documents really quickly. So let's start with 1. So what's the first thing? Well, what's the project objective? And notice on how I'm not writing the README. It is a good practice to write a README like so, but I want to get all of my ideas down first, and then we do a little bit of the project, and then we write the README from what the core of the project looks like. So let's start with summary. And this is kind of going to end up looking like a README, and we could take pieces and parts of it, but it's not really a README because some of this information in this document I don't want to be explicitly shown when you actually deliver the content to consumers. So summary. What are we trying to accomplish? And I think I told you about this the last episode, but if that's not the case, then we're going to type it out aloud. So Infinity is an open source software project designed to assist programmers and other designers in real-time cross-communication between platforms. Now this sounds like a mouthful, but let's digest what this is. This application will behave similarly to Google Docs, which is a real-time synchronization text. Well, it's not really text editor. It's like a word text editor. I guess it's just an overpriced text editor. Oh yeah, there's a line here, so let's go ahead and cut to a line. Real-time communication similar to Google Docs, which is real-time synchronization test editor. This, however, it will also include various other necessities, such as code and art, and really modeling. Modeling is my best bet. So this would be kind of like shoving Blender in here, or something like, because we're going to take an whole entire IDE and we're going to crunch it down into this project that we're making, and it's going to be massive. But that's our ideas. I don't think there's really much to add. Add ideas.md. And then what we need to do is that we need to go ahead and figure out what we actually need, because the bare bones GUI application that looks halfway decent looks like this. Let's put in a menu, border pane. Oh, come on, thank you. This, and then border menu, which is something to stick menu bar. So it looks like that. And we have this guy, which we could just put as content, but I'm not sure what I'm going to put here. I think in some iterations, in some previous versions I've designed this, I typically put a tab pane here. And I think a tab pane is a good best bet, because then we can have multiple tabs at the same time. And then unfortunately we can't figure out how to do this. We'll figure out how to do a split view. So let me just delete both tabs, since both of them don't really apply at this moment. And then we just name tab pane to content pane. Content pane, thank you. And a file, let's just rename close, because it generally makes sense to call close and call exit, because close just implies closing a window. We really want exit, right? So let's hop into our display class, display, here we go. And XML, public void exit, platform.exit, XML, and then we have this GUI component of this tab pane, so we have content pane, private tab pane, content pane, like so, and that's going to show it up like that. So when we run this, let me remove this runtime configuration since it doesn't work. Run this one app. It's going to appear on my second monitor, which is my main monitor actually. So I'm going to have to drag it over here, so don't mind me doing that. Build, target, come on. It's going to appear on this monitor. Hold on. I could not find a load main class. com.metri.app.main. Interesting. That's clearly valid. Interesting. Oh, here we go. Infinity. Let's delete this because otherwise it just doesn't detect the name. Like so. Version 1.1. Not going to change it up the version. Doesn't really make sense. Yeah, so it's just going to search the packages, which is why it probably wasn't scaling up properly. And come on, SPT. Oh, I don't like red. I don't like red. I've been module not specified. Yeah, here we go. Delete. Okay. Main Java map. Run. Plus work. Alright, here it goes. Here we go. Yes, that works. Come on. But it pops up before fxml as shown. Now, and we have exit, which just exits the application, which understandably happens so. Now, the thing is that I've done a lot of pre-testing and trying to figure out how to get a lot of things to work. So let's go ahead and do that. But that's our display. And so what we're going to do is that we're going to figure out a few things. We have to figure out how to make a way to distribute connections and a way to connect to connections. Now, what happens is that I'm not going to do the implementation of that. I'm going to apply a simplistic implementation from basic Java I/O that just push that while I'm talking. But through like sockets and socket servers, which isn't really server sockets, which really isn't that reliable at the end of the day. But as we continue down this series, we'll explore other options like hosting a web server and things like that. So it's going to be an open-ended thing. So let's hop. Did I commit this? Update implement in some portions of display.xml. Come on. Thank you. So let's do this. And what do we want first? Well, we want our client view and we want a server view, because our client view tells us what's going on in our clients, and our server tells us what's going on our servers. And we might not even have a server. It could be a, I don't know, it could be a P2P network, but it's still just going to be a network manager, if that's the case, like a network manager. So if that's explicitly a server, that's explicitly a server. But we're not going to deal with that yet. So what I'm going to do is that under display, since we have, no, go away, open scene builder. It's probably already open, isn't it? Yeah, it's open. We are going to go under, let's make a new menu. Menu, so let's stick it right, edit, view. Like so, and let's call this guy view. And under here, I'm going to specify the different types of windows that we want, and you can see it's right here. So we can do, actually no, I'm going to delete view for a second here, and I'm going to add a new thing to file. A file, and let's just do something along the lines of connect to a, find a connect, come on. Find a connection, thank you. Let's go to There's going to be host a server, and then host a server, and then create come on, local server, like so. Expand out a bit, and let's go under, and let's make these things. So what we're going to have to do is that we have to assign these to specific methods in the fxml. So like find a connection here, and host a local server here. Host a locals. Like this, and then create a local server. So let's go to display, and it's going to plop this guy here. Public void find a connection void host a server. Public void create a local server, just like so. And that's just gonna plop it in there, and and close this out. Come on. Okay, that's fine by me. There we go. So these just automatically are menu items that are invoked. Add menu items to display. And what we want to do now is, oh no, there's an error. Let's find the error. Let's hit compile. There should not be an error though. I'm not sure why there is an error. Hit compile, it seems. So I have no idea why there's an error. Center. Host a local I thought it says what? Huh. Okay, so I apparently punched it in. I punched it in wrong. So let's just edit this manually so I don't feel like going to center it. Host a server. There we go. Resolve problem in display.fxml. And no, I'm not describing the problem because it's self-explanatory. Because it's in the method that was specified in the fxml, it's not the same as in the controller. So, probably in the next few episodes is going to be a lot of boilerplate code, just trying to get an overhaul of what the application needs to be done. What needs to be done for the application. So I will go ahead and record all of this, but I won't have any commentary also because my voice is at the moment from talking from the past 23 minutes and so. And let's see here. So if you're hitting Scene Builder, it's going to go ahead and display that, but it's not really going to give us anything. And so that's what we want. We want to be able to do those kinds of things. So find a connection, host a server, create a local server. So let's see here. How are we going to do this? Let's think about this architecturally. So my idea is to have these things automatically create other fxml in a different stage, and I wanted them to be in different stages because I want, come on, thank you, I want it on this screen. Everyone loves paint, even though it's just decommissioned, everyone still loves it. So what happens is that we have our main class. Okay, that's not helpful in any way, shape, or form. So, and then we have various different controllers. Let's just do green. Because one of these could be the display. It could be, I don't know, this one, or this one, or this one, or this one. But it's not important. But in reality, is that every other thing has to connect to each other. I mean, not thing. I mean a controller. So this would have to connect to this. Would have to connect to this. You have to connect to this. It might not necessarily, but we have to imply that the connection is there. And as though it just ends up being this huge entangled web, as you can see, even just by visualizing it. So now we solve this, we need a central thing. So if we just send whatever state here, then architecturally this should be a good idea. And what happens is that this keeps track of something called like a state inside. So state. And this allows our server to basically control what we're doing. It's to black because that's an operation. But the main method invokes this controller, which invokes this display and then just cascades like this. So we need to figure out how to build this object at the moment, and I've done this multiple times, so I'm just going to lecture on it. Let me push the commits. There we go. But let's go ahead and make a new utility class, and we're going to call this guy state, and it's going to be exactly like what we just described. It's going to be an internal state. And what happens is that the idea is that every controller that we make has access to this internal state, and the way we give it access to this internal state is through a controller class. So let's just call this home.meti.lib.fx.controller, like so. And so let's have display and extends controller, and we can't put anything in the constructor because the fxml loader loads the default constructor. But what we want to do is essentially just do private, or really protected, state, where state could be really anything. Now what I want is that I could possibly want a certain type of state, and I'm going to explain why I want a certain type of state. As extends state, because there are certain cases where certain types of states are necessary. It could be an internal state, it could be an external state, and that just runs into the what's it called, .core, because this is the core part of our application module system down the road. So now what happens is that we have state, we have access to this, and I want a specific type of state called an infinity state, which is the specific state that our application is going to use. Again, we're making an abstract thing, infinity state, and it's going to have an extend state. And the reason why we have this is that it's just good architecture, because we keep the things in our application separate, and then we have things that could potentially be turned into a library in lib. So state is one of those things that, and we could end up turning into a library down the road. Not yet, but we don't need that. Now the issue is that in the state, one, we don't know what state is. It's just an object of empty field, so it doesn't do as much. But we also don't really have access to anything involving a state. So let's just add a commit, adds state, etc. And then what we're going to do is that we can't really add what the state is, so let's go into infinity, and I'm going to do something like this. Let's stick this down this, and this doesn't really make sense. And I'm going to put private infinity state, private final, infinity state, state. And what happens is that a state's going to hold a bunch of multiple variables together intentionally. It basically is just a container, but it's a special type of, it's really actually just an overpriced collection of things, but it's a very specific type of collection. You see, I'm going to sort things based on, what's it called, class. So let's say there's some things of strings, there's some things of, I don't know, ints, there's something of, I don't know, points, that's aw.point, or something like sockets, I don't know. So it's all like this. And it's really difficult to quantify since none of these really have a common type measure, right? This means that if I had something like car, truck, and airplane, it would all be under a type measure of vehicle. Or like a superclass that we could all find a commonality. But they're also different, so it's really difficult to find something like that. So let's go ahead and let's do buckets. It's going to be a bucket system. So let's go ahead and do. I'm going to draw a bucket to the best of my ability. which is not that much of an ability, but you know, like this, like this. That really should be a rectangle, whatever, and then something along the lines of this again, right? Okay, good enough. It's gonna be a bucket that you can see through, and then just switch this to white since that's kind of annoying. Okay, so now the reason why I have this bucket is so we can just copy and paste this multiple times. Boop, 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 boop. That was not very effective, was it? Boop, boop, doo, doo. Boop, doo, doo, doo. But so we have multiple buckets, and each bucket has a certain class on it. So let's just type in string. And this is a really important part because it's a new data structure. I think that kind of pertains to this project. So string, and let's do something along the lines of, let's do point. This is follow the examples that I used before. Points. So let's have a bunch of points. Or it could also be a bunch of controllers, you know? So we can attach a bunch of controllers to the internal state, and this is how the controllers can access to each other. Let's change the font down since you can't really detect that the font is a good size. Thank you. But it's kind of this case in point, and this is bugging me, so let me just move this aside. Thank you. Move this a bit up. Thank you. Much better. And this is not the same font, but we're going to ignore that because this is just a huge font. And my voice is getting tired, but whatever. But product alert. What we need to do is a bucket system. And we're going to call this guy what's something that makes buckets? Because there's this old-fashioned occupation in which someone made buckets. I might be thinking of a cooper because a cooper makes barrels, but someone that makes buckets. Let's see here. Bucketeer. Well, it does look. It seems that a cooper did just do the same things and made buckets, but regardless, we are probably not going to name this a Cooper data structure. So we probably need to think of something different. So if you think about this as a shelf, and each book being a different series, what we can do is that this can really be like a bookshelf or really a drawer. Because in mathematics we have, well, really not in CS, we have lists, we have sets, we have queues, we have stacks, we have trees, we have a wide variety of things that's taken off of examples from real life. So why don't we just have something called a shelf? A shelf. So a shelf class. And a shelf contains multiple types that's punched in by delimiter. And in this case, our shelf class is going to be built on classes. Now this could also be a different boolean, etc., etc. But let me just save this into the folder, scratch shelf diagram, so you guys have access to that image. Create idea of shelves class. Boop, and that's obviously the image, right? Content add. So let's go ahead and make the shelf class. And I want this important because the state's going to extend a shelf class. So it's going to extend. It's really going to extend a shelf, but it's going to be a specific type of shelf. It's going to be more like a class shelf, or something like along the lines of that. So let's go ahead and do something like this. State extends shelf, like so. And our core, we're going to change it to collect because we're making a collection. And we can see this projects are getting very large very quickly. So what is a shelf? So essentially, you remember that things needed a certain type of predicates, basically a way to sort things through. So a predicate of, I don't know, question marks. And actually no, we're going to put this on object O. A predicate O, P extends predicate P. And the only downside to this scenario is that it shouldn't extend P, it should extend O. And what we can do is that we can do a wide variety of different things here. We can make this super abstract if we wanted to. So let's go ahead and do something along the lines of this. We need a predicate. So let's do final P predicate. Actually no, extends. And we can't do a class map because when you do not a class map, I meant a hash map. Because what happens is that the computer is assuming that the two generic types are the same. You can never actually programmatically check. So to do this safely, we do something called a private static class shelf stack. I don't know, really a binding shelf. Let's just call this binding for shorthand. And the purpose of this binding is it's not going to be static because we're going to delink the instance. Is that it associates it from the private final P predicate, and we're going to have private type of C, and then C is going to be a type of content. And I have no idea what C is going to end up being because C could be anything. So it needs to be an abstract thing. C extends abstract. O extends O binding, and then we could do is that we do delegate method P. Actually no, we don't want to do that. Extends hash set of binding. So oh come on, why isn't that working? Fine, we'll do public, whatever, because we don't really need access to that. I don't want the thing to be internal because then we can't do streams and things. We can't stream the shelf. We should be able to stream the shelf, so that's why I'm concerned. But let's say we choose to add a new object, public void add object. Public void add object. That just overrides it because it's a different method type. Object C. And now what happens is that we need a way to handle C, because C's are binding. But we have no idea how to handle the operation when O is added to the binding or when O is removed from the binding. This could just mean that O is singular, or O could be a collection, or O could be in a different space, or O could be whatever. It doesn't really matter where O goes, as O gets assigned to C. And that's kind of difficult to do. So here's what we're going to do. We're going to go into binding, and we're going to add a new method that goes something along the lines of this. Let's just go down here for a second. Binding, and then we really need private C content. That's what C stands for. Add construction parameter. And this is just default content, and I'm just going to change this to be public, so it's easier to code from the class above. It probably doesn't have to be public though. Yeah, it doesn't have to be, but we're going to make it public anyways. So add object, and we're going to do something like this. So it seems that we have a shelf of bindings, so we can do a stream dot map new any, because we can use a lot of streams here. Dot map. No, actually, we have to do something like this. We have to, oh yeah, binding's gonna end up being an, oh no. Oh no. Oh no. Because I'm not sure if the internal structure should be sets of buckets. Let's make it a set. Because sets really shouldn't matter, because this is just a bucket system. I don't really care what the books are on my shelf. I just care that they're public final hash set of, thank you, of O set equals new hash set. And so we can remove this parameter right here. And yeah, that just shoves it up there. And we could probably make this predicate public. And the reason why I want these things public is that it's easy to code from up there. I don't actually have to go ahead and physically type out the whole entire thing. So let's do stream content stream dot map function equals new predicate O function binding dot filter. We actually need a filter. New dot stream dot filter new predicate. And actually no, yeah, this should be okay. Predicate return binding dot predicate dot test object. And that allows us to do that. And we new map, new function object set of O return binding dot content dot for each new consumer rows dot add object. And this makes sense to me at least. What's going on here? Shelf dot binding to anonymous. Huh. This is something new. Cut. Return. True. Huh. Can we seriously not stream this? We should be able to stream this. Interesting. Huh, so we have to do that. That's kind of annoying. That's the way inner classes work. Let's rename this to be shelf binding. No, unselect. I do not want those things to be renamed. Move this upper level to the class, so just extracts it into its own class. Type parameter. Type parameter. Okay, so now it should be okay. Test. Why is that an object? P test. Hash of self-binding. Oh, P. O, P. Remove that. Yeah, so this is becoming much cleaner if we just a predicate return OP. That predicate dot test object. And so this gives us this. Let's just move it around. So this just says add object and just adds the object to the thing, which is kind of important. So this is our shelf. And we actually don't need this abstract keyword anymore because it doesn't make sense. But add shelf. So it's really just a bunch of things sorted by predicate, which makes sense. We just test if it has the predicate, and we just add the object if it has the predicate. So state extends shelf, O, since object, and then predicate. And now what we want to do is that we can just do a special type of predicate. Public void add predicate and bucket. No, create bucket, because that would make more sense to me. Create bucket. And actually now, yeah, let's change this to shelf bucket. Because we're just working with buckets, right? So create bucket. Return add shelf bucket OP bucket. Just new shelf bucket. And here we're gonna plop in it requires a P predicate. P predicate. And it's going to return add bucket, return bucket, just like so. So add shelf dot create bucket predicate. And that's the refresh method in your commits. So let's see a shelf class shelf extends shelf, and then O is going to be object since we have no idea, and then predicate is going to be a class predicate. And this really, the class predicate can really be anything. But I'm going to just go on a tangent here and show something called a converter. So let's do convert.converter interface. And it's really simple method. So it's default. Actually, let's change this to an abstract class. Public boolean can convert, and then public okay, this recording is getting really long. Implements predicate of O, converter of O, I to O, because we're converting something from input to output. We test I, then map a function of from I to O. Can convert, return, apply, return test, I input, I input, public O convert, I input, return, apply, input. And the reason why I'm doing all this is that if can convert input, and let's throw new legal an exception, cannot parse input. So, and we can do a class predicate like so, really a class converter. And we need a lot of class converters down the line, which just a useful structure to have. Extends converter of input of type object, output type of, I don't know, T. And then we do private final T class, T type class, because that's really what it means. Apply return type class dot cast O test. And now this is where the test is important because we don't know if it's going to be boolean equal is subclass use subclass, and let's do append, and we're going to make a new generated constructor with this true. Cut out, and let's just do something like this. So if use subclass return type class dot is assignable from ODK class, else return type class of equals ODK class, because sometimes with these class converters we might want a more precise thing, like exactly equals, but sometimes we just want to detect if it's some kind of instance of another. And that makes it castable. So shelf extends class converter of T object. Really object of question marks, because I don't know what, because it really just depends on the variable bunch of classes. Public void add, let's look at some examples. Public void create bucket class type class return create bucket new class converter type class use subclass, and I just stick use subclass in there. But that's just going to sort everything into buckets. And converters. Let's just versionify this for a second. Add class shelf. So I'm going to wrap up the episode here, guys. I hope you enjoyed the episode. It was kind of long because it was just me muttering to myself. And also my voice is kind of tired for talking for about an hour straight. But I hope you enjoyed the video. Next time we're going to see, I told you, a lot of boilerplate code that we just have to get through. I probably would just do a lot of this in my backend. But I hope you enjoyed the video, and see ya.